In research, the concepts of samples and sampling are foundational. A sample is essentially a smaller, manageable version of a larger group or population. Researchers use samples to draw conclusions or make inferences about the larger group without examining every individual member. This approach is crucial for efficiency and practicality. Sampling refers to the process of selecting these smaller groups. It's a method used across many fields, including market research, psychology, and the social sciences. By focusing on a sample, researchers can study patterns and make predictions about broader populations. This process is both strategic and systematic, ensuring that the sample accurately represents the group. The effectiveness of sampling hinges on how well the sample mirrors the overall population. A well-chosen sample can offer insights that are almost as accurate as studying the entire group. This makes understanding their principles of sampling vital for any research endeavor. The selection and method of sampling can significantly impact the reliability of the research findings. Sampling is a nuanced process with various techniques, each suited to different types of research and goals. Whether for academic, commercial, or scientific purposes, mastering sampling techniques is a key skill for researchers. It ensures that they can conduct studies that are both cost-effective and representative. Sampling is a cornerstone of research methodologies due to its numerous advantages. One major benefit is cost-effectiveness. Studying a sample instead of an entire population can significantly reduce the financial resources required. This economic efficiency allows researchers to allocate funds to other critical areas of their study. Time saving is another significant advantage. Collecting and analyzing data from a sample requires less time than attempting to do so with an entire population. This is especially beneficial in fast-paced environments where timely results are crucial. Quick data collection can lead to faster decision-making and implementation of findings. Sampling also addresses feasibility concerns. In many cases, it is impractical to gather data from everyone in a population due to logistical constraints. Sampling provides a practical solution by allowing researchers to work with a subset that is still representative of the whole. This approach makes large-scale research projects more manageable and achievable. Moreover, sampling can enhance data quality. A well-chosen sample can offer insights that are just as reliable as those obtained from the entire population. This is because the sample can be carefully constructed to reflect the diversity and variability of the whole group. This precision ensures that the conclusions drawn are robust and applicable. Sampling techniques are diverse and can be broadly categorized into two main types: probability sampling and non-probability sampling. Understanding these categories is essential for selecting the appropriate method for a research project. Each type has its own methodologies, advantages, and challenges. Probability sampling involves methods where every member of the population has a known chance of being selected. This ensures that the sample is representative of the population, allowing researchers to generalize their findings. Common probability sampling methods include simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Non-probability sampling, on the other hand, does not provide every population member an equal chance of selection. This can introduce bias, but it is often used for exploratory research where the focus is on gaining initial insights. Techniques under this category include convenience sampling, judgmental sampling, snowball sampling, and quota sampling. Choosing between these techniques depends on the research objectives, the nature of the population, and available resources. Probability sampling is often preferred for studies where precision and generalizability are crucial. Non-probability sampling is more suitable for preliminary research or when the research conditions are restricted. Each sampling technique has its strengths and weaknesses which researchers must consider. A thorough understanding of these methods enables researchers to select the most suitable approach for their studies, ensuring valid and reliable results. Probability sampling is a method where each member of the population has a known, non-zero chance of being included in the sample. This randomness eliminates selection bias, making the sample representative of the whole population. Simple random sampling is a fundamental technique in this category. Simple random sampling involves selecting individuals completely at random. This can be done using random number generators or drawing names from a hat. Its main advantage is that it reduces bias, but it requires a complete list of the population, which might not always be available. Systematic sampling is another probability method where researchers select every nth member from a list. A random starting point is chosen, and then every nth person is included in the sample. This approach is simple and ensures even coverage, but it can introduce bias if the list has a periodic pattern. Stratified sampling involves dividing the population into subgroups or strata based on shared characteristics. Samples are then drawn from each subgroup. This ensures representation from all subgroups, increasing the precision of the results. However, it requires detailed population knowledge, making it more complex. Cluster sampling divides the population into clusters, often based on geography. Entire clusters are then randomly selected for study. This method is cost-effective for large populations, but can result in higher variability, making it less precise than stratified sampling. Section 5. Exploring non-probability sampling. Non-probability sampling methods are useful when probability sampling is impractical. These techniques are often employed in exploratory research where the goal is to gain insights rather than to generalize findings. Convenience sampling is one of the simplest forms of non-probability sampling. In convenience sampling, researchers select individuals who are easy to reach. This method is quick and inexpensive but carries a high risk of bias. The sample may not represent the entire population, limiting the generalizability of the results. Judgmental or purposive sampling involves selecting individuals based on the researcher's judgment. This approach is useful for studies with specific objectives, but is subjective and may not accurately reflect the population. It's ideal for in-depth studies where specific expertise or characteristics are needed. Snowball sampling is used for reaching populations that are hard to access, such as marginalized groups. Initial subjects recruit future subjects from among their acquaintances. While it helps reach difficult-to-access populations, it can lead to biased results as the sample tends to be homogeneous. Quota sampling requires setting quotas for different population segments and filling them as conveniently as possible. This ensures representation of specific characteristics, but since selection is not random, bias can occur. It's practical when time and budget constraints are significant. Section 6. The sampling process in research. The sampling process involves several key steps that ensure the sample accurately represents the population. The first step is defining the population. Researchers must clearly specify the group they are interested in studying to ensure that the sample reflects this population. Once the population is defined, the next step is determining the sampling frame. This involves identifying a list or method to reach the entire population. A well-defined sampling frame is crucial for ensuring that every member of the population has a chance of being included in the sample. Choosing the sampling technique is the next critical step. Researchers must select a method that aligns with their research objectives, the nature of the population, and available resources. The choice of technique can significantly affect the research findings' validity and reliability. Deciding the sample size is also important. Researchers need to balance statistical power and resource constraints to determine how many individuals will be included in the sample. A well-calculated sample size ensures that the results are statistically valid and reflective of the population. Collecting data and analyzing results are the final steps. Researchers implement the chosen sampling method to gather data from selected individuals. Statistical techniques are then used to analyze the data and draw conclusions about the population, ensuring that the study's findings are robust and credible. Section 7. Factors influencing sampling decisions. Several factors influence decisions about sampling methodology. The purpose of the study is a primary consideration, as different research questions may require different sampling approaches. For instance, exploratory studies might use non-probability sampling, while quantitative studies often need probability sampling. The characteristics of the population also play a significant role. Diverse populations may require stratified sampling to ensure all subgroups are represented. In contrast, homogeneous populations might be adequately sampled using simpler methods like random or systematic sampling. Resource availability is another critical factor. The The time, budget, and personnel available can limit or enable certain sampling methods. More complex methods might provide better data but require more resources, while simpler methods might be more feasible with limited resources. Desired precision impacts both the sample size and the choice of sampling technique. Studies needing high precision might opt for stratified or large sample sizes, while less precision might be acceptable for exploratory studies. Researchers must weigh their needs against practical constraints to choose the best approach. Considering these factors ensures that the chosen sampling method aligns with the study's goals and constraints, enhancing the validity and reliability of the research outcomes. Section 8. Determining sample size. Determining the appropriate sample size is vital for ensuring research results are statistically valid and reliable. The size of the population is the first factor to consider. Generally, larger populations require larger samples, but this is not always linear and depends on other factors. The margin of error is another critical consideration. A smaller margin of error means the results will be more precise, but it requires a larger sample size. Researchers must decide how much error is acceptable for their specific study to balance precision with practicality. The confidence level indicates how sure researchers can be that the population parameter falls within the margin of error. Common confidence levels like 90%, 95%, and 99% require progressively larger samples to ensure accuracy. Choosing the right level depends on the importance of the study's findings. Finally, variability within the population affects sample size. More variability means a larger sample is necessary to capture the population's diversity. Researchers must assess the expected variability to determine the sample size needed to achieve reliable and generalizable results. Balancing these factors is crucial for calculating a sample size that provides accurate insights without overextending resources, ensuring that research conclusions are both valid and practical. Section 9. Conclusion. The critical role of sampling in research. Understanding samples and sampling techniques is crucial for conducting effective research. By selecting a representative sample, researchers can draw accurate conclusions about a larger population without needing to study every individual. This process is both time-efficient and cost-effective, making it an essential tool in many research fields. Probability and non-probability sampling methods each offer unique advantages and challenges. Probability sampling provides a framework for generalizing results, while non-probability sampling is useful for exploratory studies. The choice between these methods depends on the research objectives and constraints. The sampling process, from defining the population to analyzing results, requires careful planning and execution. Factors such as the study's purpose, population characteristics, and available resources influence sampling decisions. These considerations ensure that the research is valid, reliable, and applicable to real-world scenarios. In conclusion, mastering sampling techniques is vital for researchers aiming to produce credible and valuable insights. By understanding and applying appropriate sampling methods, researchers can enhance the quality and impact of their studies, contributing to knowledge across various fields. Sampling remains a key element of research methodologies, underscoring its importance in achieving accurate and meaningful research outcomes.